This is Audacity, and it's a free program that you can download to play around with sound. And what we're going to do here first is generate a tone based on our trigonometric functions. So we can use this sinusoidal waveform and the frequency of 440 hertz. We can determine an amplitude, which would be how loud it is, and a duration of time. It's going to be 5 seconds sine tone. And Audacity will generate that for us, and we can play that tone, and you can hear the oh no, try changing the post playback device sample product rate. I'll fix that. Okay, trying this again, we can play this sound, and hopefully that you can hear in the recording that 440 hertz tone. Similarly, we could generate other tones that were a different frequency. Change that to 240 and maybe decrease the volume or the amplitude, generate this tone. Again, we can zoom in and begin to see that sinusoidal waveform and play it. And there's that lower pitch that we get from a shorter frequency or longer wavelength, I should say. So that's one way that you can experiment with playing around with sounds. But an interesting thing happens when we add these two together. So I'm going to add a new track to this thing we're playing, and I'm going to generate a new tone, and I'm going to offset the frequency from 240 to 248. And the same amplitude, the same waveform. And now what I have here is a slightly different frequency. From 240 and 248. And when I play this, what I hear is the offset or the interference of these two wave patterns. So what you're hearing there is that 8 hertz wobble, the difference between those two waves as they interfere with one another on your ears. So let's take a look at how that appears when we're dealing with the functions and how they appear.